from West Virginia Public Broadcasting.
Support for the following is provided by the West Virginia Department of Education and West Virginia Public Broadcasting. Hey! Hey everyone, it's Education Station!
Hi, and welcome to Education Station. I'm your host, Alex Milanese. Education Station is a show where we invite teachers from all across West Virginia to submit videos of themselves teaching their favorite lesson. On today's episode, we're going to get to visit 3 exciting classrooms at Kellogg Elementary School in Wayne County. Now, before we get started, if you've ever baked a cake, well, you know fractions are really important. Too much flour or not enough, and the cake doesn't turn out right. So, to learn more about fractions, let's go visit Miss Maggie's classroom.
My name is Miss Maggie. I am a 3rd grade teacher at Kellogg Elementary School in Wayne County, and today I'm going to teach you an introductory lesson to fractions. We are going to work on understanding what fractions are, understanding the parts of a fraction, learning a couple vocabulary words in there, and we're going to do an activity at the end that you can do at home with your families. So the first word that we need to discuss for vocabulary is numerator. So numerator, and I'll write it on the board for you. Numerator is the top of the fraction. It's the first number in a fraction. So if you have a fraction, let's do 1/8. The top number is your numerator. Then we have denominator. Also writing this up here for you. Then we're going to do the same fraction, same numbers. So you have 1/8 and 1/8. Numerator is the top, but denominator is going to be your bottom number. So let's do a little activity to kind of help you remember what numerator and denominators are. So everybody stand up. All right. So numerator, and you're going to get on your tippy toes for this. Numerator is the top number, and back down. And then denominator, we're going to squat down really low for this. Denominator is the bottom number. Okay, so let's do it again. Numerator is the top. Denominator is the bottom. All right, very good. So everybody go ahead and sit back down. Now that you know what numerator and denominator are, we're going to talk about what a fraction is. A fraction is a piece of a whole. When you have a piece of a whole, one piece is not going to be your entire amount. So let's think of pizzas. If you get a pizza, which is cut into equal portions, fractions are always in equal parts, so every 1/8 is going to be the same size. So if you have a pizza and you took it home and you're ready to eat it, you take one slice out. There's one piece of your whole pizza missing. So if you take one slice out, we're going to learn how to decide what part of your pizza is gone. So you have, here's your whole. Go ahead and put this on the board here. Here's your whole pizza. Now, I'm not the best artist. I know some of you all may not be either. Some of you may be great, so forgive me if they're not exactly equal. So here's your one whole pizza. Whenever you get your pizza, though, you don't just cut it in half. We're going to cut it in more pieces. So, here's your pizza. You open the box and you're ready to eat it, and you notice there are pieces. So we have 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 pieces. You're open the box and you're getting ready to eat it, and your mom says, take one piece out. So you eat one piece of the pizza. This is one part of the pizza. You still have 7 pieces left. So we're going to talk about what part or what fraction of the pizza you ate. So a fraction is part over whole. So first off, guys, how many pieces of pizza were in your whole pizza? Okay, 8. Good job. So remember, denominator's your whole. Denominator's your whole. And then how many pieces did you eat? 1. Okay, good. So that's your part. You ate 1/8 of your pizza. So you ate 1/8 of a whole pizza. But let's see how much your whole family ate. So if your family has 4 more people other than you, 5 total people, everybody eats 1 slice. So you've already ate 1. Your mom comes along and eats another one. Your little sister says she's hungry, so she's going to eat another piece. Your brother says, oh, I'm still hungry, so I'm going to eat another piece. And then your dad comes by and says, well, I may as well eat some too. So if every person in your family's ate a piece of pizza, how many pieces out of your whole have been eaten? Let's count them. We have 1, 2, 3, 4, 5. So what fraction of the pizza did your family eat for dinner that night? You gotta think about it. Good. We have 5 pieces. And how many total pieces were in your pizza? 8. So you have 5/8 of your pizza that has been eaten. So we have learned numerator, denominator. Numerator is the top, denominator is the bottom number. Then you have a fraction is part over whole. Numerator, denominator, part over whole. So you know that your pizza has, let's see how many it has left though. You know how many you've eaten. But how many pieces are left? How many do you have for lunch the next day? So if you come through and you count, well, there were 5, we already ate, but how many more do I need till I get to 8? So let's count. You have 1, 2, and 3. So we have 3 pieces left. What fraction of the pizza is left for you to eat for lunch the next day? Now it's a fraction, so you have to have your part over your whole. We're going to think about it, and then let's go ahead and put it on the board. So you have 3 pieces left. You have 3 pieces left. How many pieces did you start off with? You have to think of how many you started with, how many was in your whole pizza. And we know that was 8 this time. So 3/8 is what you have for lunch the next day. So now we are going to do a little activity, and I'm going to show you a little visual first, and then we're going to do a little activity that you can do at home. So if we want to look at our manipulative, let's do a little hands-on, we have a whole pizza. Let's pretend this is a pizza we just talked about. So you have a whole pizza, and this pizza is made up of 1, 2, 3, 4, 5, 6, 7, 8 parts. And you can see that each slice has 1/8 written on it. So each slice is worth 1. So you have 1 piece that has been eaten. Then, how many pieces are left out of your whole? Your whole doesn't change just because you've eaten 1 slice. You still have 8 total pieces that you started with. So you have 8 total pieces. Even though 1's already been eaten, your whole is still going to be 8. So your denominator is still going to be 8. Now, every piece that you take out changes the fraction that you've eaten. So you're still hungry after your first piece. So you decide you're going to eat a piece with green peppers and a piece with olives, mushrooms, and pepperoni on it, and peppers. So this right here is what you've eaten. So you still have 1, 2, 3, 4, 5/8 of the pizza that's left, and you have 3/8 of the pizza that you've already eaten. You've already eaten it, so we're going to put it over here. So here's what's left.
All right, thanks, Miss Maggie. All that talk about pizza really got me hungry. Speaking of food, our next teacher, Miss McCoy, has a delicious way to talk about area and perimeter using my favorite snack, Cheez-It crackers. Let's check it out.
Hi, my name is Miss McCoy. I'm a 4th grade teacher at Kellogg Elementary School in Wayne County, West Virginia. And today I'm going to go through an investigation with you on the area and perimeter of rectangles. To begin with, we're going to start with just a basic review of perimeter. Perimeter is the measure of the distance around an object. We've got this great little picture here to illustrate that for you. The perimeter is the measurement of the distance around the outside of an object. The formula that we use to find perimeter is side plus side plus side plus side. You can also do 2 times the length plus 2 times the width to find perimeter. When I go over perimeter with my students in class, I tell them to remember that inside the word perimeter is this word, rim. When you think about the rim of a glass, you think about the distance around the edge of the glass. And that's what perimeter is. Maybe that'll help you remember perimeter. Whenever we talk about area, we always talk about arrays. I know that you've seen arrays before. When we are measuring area, we are looking at the number of square units it takes to cover a flat surface. The formula for area is length times width. Whenever I think about area, I always think about arrays. It's the number of square units it takes to cover a flat surface. Well, today for our investigation, here's what we're going to do. I have the following challenge. Julianne is in the art club at school. The art teacher has asked Julianne to create a drawing of a spring landscape for the upcoming art show. Her art teacher has challenged her to create this landscape using only 16 square inches of paper. What are all the possible dimensions of rectangles that can be created with just an area of 16 inches? Which of these rectangles has the greatest perimeter? Now, if we were in my classroom, I would pull out my 1-inch tiles. I would give you 16 of them, and we would start to arrange the tiles, all 16 in different rectangle shapes, to see the different dimensions that we could create. Now, I know that you're at home and you probably don't have 1-inch tiles, but you may have a Cheez-It. So I am going to solve Julianne's art problem today using Cheez-Its to represent my 1 square inch. Now, just like I said we would do with the tiles, I pulled out 16 Cheez-Its and I arranged them the first way that logically occurred to me. I did 1 row of 16. Then I calculated the perimeter for that and the area. To find the perimeter, I said side plus side plus side plus side. That would have been 16 across the top plus 16 across the bottom plus 1 for each side. That would give me a perimeter of 34 inches. Then I calculated the area. I said length times width equals area. The length is 1 inch. The width is 16 inches. So 1 times 16 equals 16 square inches. Whenever we label area, it is important to label it with square inches. That's the number of square units it takes to create the rectangle of 16 by 1. Now, if I were to just turn that rectangle, I would still have a 1 by 16 dimension, but this time I'm going to have a length of 16 and a width of 1. Now, when I do that, the area and perimeter will, of course, stay the same. The area will still be 16 square inches, and the perimeter will still be 34 inches. But this would be the first way that I would try to arrange my Cheez-Its using my 16 Cheez-Its to figure out the shape of my spring landscape. I would then move on and I would think, well, I tried 1 row of Cheez-Its. Let me try 2. And so I did. I did 2 rows with 8 Cheez-Its in each row. I created an array, didn't I? I have 2 by 8. If I were to multiply the length times the width, I would get 16 square inches because I'm still using 16 Cheez-Its. My area isn't going to change, but what is going to change is my perimeter because now I've arranged my Cheez-Its in a different way. I have a perimeter of 8 plus 2 plus 8 plus 2. That gives me a 20-inch perimeter. It's amazing to me that the same 16 Cheez-Its create different rectangles. Let's turn this rectangle and look at it. If we had a length of 8 inches and a width of 2, of course, the area and the perimeter remain the same because all I've done is change the orientation. I've just flipped it. The perimeter is still 20. The area is 16. So now I've got a 1 by 16, a 16 by 1, a 2 by 8, and an 8 by 2. Whew. Okay, let's try with 3. So I then began putting my Cheez-Its, my 16 Cheez-Its, into 3 rows. When I did that though, I found that I had a Cheez-It left over. So I knew this could not be a possible arrangement of my 16 square inches. I knew that I couldn't do 3 rows of 5. I would have 1 left over that's not a rectangle. So then I thought, 4 rows of 4. I've got 4 rows in the length. I've got 4 rows in the length, and then I've got 4 Cheez-Its down in columns. So I've got side plus side plus side plus side. That would be 4 plus 4 plus 4 plus 4. And that gives me a perimeter of 16 inches. It also gives me an area of 16 inches because I am going to multiply my length by my width. 4 times 4 equals 16. So these are the different designs that Julianne could use for her art project. We could do a square of 4 by 4. We could do a square of 8 by 2, 2 by 8, 1 by 16, or 16 by 1. Any of these she could use. Now remember, she could not use the rows of 3. We would have had a rectangle. We wouldn't have had a rectangle. We would have had a Cheez-It left over. So what I need to find now is which has the greatest perimeter. That was the second part of my challenge. My perimeter here is 34 inches, 20 inches, 16 inches. Well, that would mean that the orientation, the way that I can arrange my Cheez-Its with the greatest perimeter would be 16 by 1. That would give me the portrait or the landscape picture with the greatest perimeter. Now, you can try this with other numbers. You don't have to just use 16 Cheez-Its. Try doing it with 18 Cheez-Its. Try doing it with 24 Cheez-Its. Try doing it with 12 Cheez-Its. You can explore area and perimeter for a bunch of different numbers. Then, whenever you're finished with your math work, go back and try to complete Julianne's challenge. See if you can trace the perimeter of one of your rectangles and create a spring scene.
All right, thanks, Miss McCoy. Now, before we head to our last classroom, I have a question for you. What does this building, this block of cheese, and this laptop all have in common? Well, for one, they're all made up of angles. You see, angles are a helpful way for us to describe the world around us. To learn a little bit more about angles, let's take a trip to Miss Green's classroom.
Hey guys, I hope everybody is doing well today. My name is Mrs. Green, and I teach 4th grade at Kellogg Elementary here in Wayne County. And today I'm going to do a brief little lesson on angles, okay? So if you're not familiar with angles, we're going to learn how to classify them, and then we're going to do a fun little project that you can do right at home. Okay, so first off, there are 4 different angles that we're going to be talking about today. The first one that I want to introduce you to is a right angle. If you notice, this right angle is made up of 2 rays. And a ray is, if you're not familiar with a ray is two parts of a line that have an endpoint and extend continuously. So an angle is made up of two rays, and they meet at what's called the vertex. So the first angle that we are talking about today is the right angle. Now this is called a right angle because it makes a square corner and it measures 90 degrees. And when I talk about measuring, I'm talking about the space that's in between your two rays that make up your angle. So the right angle is the first angle that I want to talk about. The second one still made up of two rays, is called an obtuse angle. It's a funny name. An obtuse angle, if you can't tell here, is greater than 90 degrees. So an obtuse angle is greater than 90 degrees. It's still made up of your two rays. They still meet at a vertex, but the obtuse angle is larger, as you can see, than the right angle. The third angle I want to talk about today is an acute angle. And you can tell by my drawing here that an acute angle is smaller space here than the obtuse angle and the 90-degree angle. So by definition of these other two, we would say that the acute angle is less than 90 degrees. Okay? So, and also another good way to remember this is, what word do you see in acute? I hope everybody has guessed the word cute. Cute is found in acute. What are things that are cute? When I think of things that are cute, I think of little babies, little puppies. Little puppies are cute. Little kittens are cute. Those are all things that I think about when I think of cute, things that are little. So a way to remember the difference between your two angles is an acute angle is a cute little angle. It's smaller than the others that we have mentioned so far. The fourth angle that I want to talk about is a straight angle. A straight angle, again, is made up of two rays that meet at a vertex, like the other angles, and it measures 180 degrees. I'm hoping that you are looking at this and thinking that it reminds you of something else. What else does this angle look like? That's right, a straight line, which is why it's called a straight angle. Good, good. So what I want you to do now is I want you to take 2 minutes, and I want you to look around your house for examples of all of these angles. Look around your house, take 2 minutes, jot the things down, the items down, label them, classify them, and explain to me why they are a right angle, why it is obtuse, and why it would be acute, and why it would be a straight angle. So go around your house and look for those items now. Now, the last little thing that I want you to challenge you with is a marble maze. And this is what I would like for you all to create at home with just household items and crafts that you might have on hand. I've used a box lid. You could use a shoebox lid, or this is a lid off of a box that an American Girl doll came in. So you could just be creative. I'm sure you have something around the house that you could use. And I used craft sticks that we had, craft sticks, and I made different angles with those craft sticks. I made acute angles in here. I've made obtuse angles, if you can see. I've made right angles. I hope you can see them all in there. I made a start and a finish. And the fun thing about this activity is once you get these glued in here, I used hot glue, but you could probably use spool glue. If you don't have craft sticks, you could probably use pipe cleaners to make your angles. If you don't have a marble, you could probably use a cotton ball or a pom-pom, a craft pom-pom. And then after you make it, you have a fun little game. You put your marble at the start, and then you try to work it around until you can get to the finish. Thank you for coming to my classroom today. I hope you enjoyed our lesson on angles.
All right, that wraps up everything for us here today on Education Station. We want to thank all of the teachers for submitting their videos of them teaching their lessons, and we want to thank you for watching. We'll catch you next time right here on Education Station.